Today we will see some theoretical part in the photogrammetry. So what is theoretical part? Ground control. Okay, ground control. So what is a ground control? What is a ground control? So ground control provides link between the ground points whose position are known and other ground points which are photographed. So what does that mean? Provides a link between ground points whose positions are known and other ground points which are photographed. So see, we took the photograph, we have to assemble. We have to assemble the photographs. We have to assemble the photographs. And if see something is a ground, something is ground, we have to fix this point. Taken on point. This position is we already known position. Later some other point is there here, some other point is there here. So you took a photograph. So later you just see the photograph. See the photograph. So this point is something Q. Q is there. Where is that position? How can you find out that position? You have to position. You already know the position is here. So somewhere here. It is somewhere here. You already know the position here. Later by the photograph of other points, every point, not only point, every point, we can easily find out the coordinates in the photograph. Are understood? In the photograph, you can easily find out the positions of every point related to this point. If you know this point, position is okay. If you know the position of this point previously, that's the provides the link between the ground points which positions are known and the other ground points which are photographs. The link between, so we have to maintain that ground control to get every point's position. So not only that purpose, and another purpose also. What is another purpose? We have to assemble the photos. We have to assemble the photos. So for that position, for that assemble, at least we require some certain known points on the ground. If you know the certain points on the ground, so something which are exactly visible. See, if this is a photograph, somewhere some temple is there. If you know this is the temple, another photograph also there, another photograph also there. So in this, it has a temple here. If you know these 2 points, it's a temple, it's a temple. You have to assemble like, how can you assemble? You have to assemble like this is a temple. You have to place it like this. That's it. So you have to assemble, this is the temple, this is a temple. So you have to assemble exactly place the temple. Understood? So that's it. We have to know, we have to fix certain points on the ground. Those known positions are some highest or some significant points on the ground. If you know that points, the assembly is easy. Are understood? For assembling photographs, we require certain known position points. That is also ground. That is also required. So that's it. Not only temple, not only one point. We require certain points. Otherwise, how can you? If you see this structural way. If you see, if you only fix that only one point, you can assemble like this also. If you see, if it is the one, it is a temple. Another point is temple. So if you, how can you assemble? He assemble like this. he assembled like this. Only temple he is fixed that and he assembled like this. It can rotate, na? It can rotate. You can fix that any angle. Just only if you know only one point, you can assemble like this. You can, but it's not right way. It is not right way, na? If you know only one point. So that's why we require at least at least 4 points. Understood? At least 4 points we required to assemble any photographs. If you only know fix that only one point, you can rotate like this. You can assemble like this only. Okay. So this is not a way. So at least 4 points which are not which are not locating near. So where very these are the 4 points known it. This is very bad. So at least you have to took 1 point here, second point here, third point maybe here, fourth point here, like this. For particular one photograph, at least for minimum three, for at least not a two, not one. Okay, at least that much photo points are required to assemble. So that is called a ground control. Ground control. So first one is you have to maintain the link between the known positions to unknown position. We required known position points. Otherwise, next we have to maintain or we have to develop a map or develop a photograph of total picture, not a single picture, develop a total area. To assemble those photographs, we required certain points. That is also required. So that's why also we have to maintain certain known positions, known points. That's it. Na? That is ground control. So that's why in ground control, if you see how many types, if you see in a ground control, we have horizontal control and second is vertical control. So nothing. In a horizontal control, we will decide those points, or we will fix those points on the horizontal scale. On the horizontal scale, that means just a photograph is there. So horizontal, horizontal, horizontal. These known these positions exactly certain points. Any points. At least 4 points. Same horizontal angle, horizontal plane. Fix those points. Fix those points. Okay. In vertical plane, vertical scale. Vertical scale means see 1 point here, 1 point here. You can provide this has height. So another point, something maybe here, maybe. So this point, see this point and this point somewhere some elevation vertically. So to fix those vertically elevated points, certain points, and we have to maintain the coordinates. So that means we know the positions of those points on the ground. Later, if you took the photograph, you can fix that. Okay, these points elevation is okay. These points elevation you can fix, or we can maintain the photograph, or we can assemble those photographs with respect to this vertical scale. Okay, known points. So if you fix the points, known position points on the horizontal scale, it is horizontal control. If you fix the points on a vertical scale, that is a vertical control. Nothing more to discuss. Somewhere took examples and photographs, that is too much. Okay, that's a vertical control. So okay, so next in this only we will discuss, we don't want to discuss horizontal control, and remaining things are related with the horizontal control. Remaining is basic control and photo control. Again, two types. So what is the basic control? Basic control is just you have to fix those points on the ground. Fix those points on the ground. So fix those points. So sir, there is no known position. So there is no high towers. There is no something pond. Those are not available. So you have to place it. You have to maintain it. You have to maintain like this, sir. One point. So otherwise, put a pole at that point and paint it. paint it by white color, not a white color, so different color, paint it. Some other point you have to paint it. You have to mark it. Mark those points by manually. Mark those points manually. Later one you photographed those picture, you got that photo, you got that picture, then you can identify those points. Exactly, you can identify those points on the photograph. Based on that, you can find out the positions of the other points, and also you can easily connect with another photographs. That's it. This is called basic control. You have to mark it. Mark those points by manually. Got it the point? So that's it. So what is the photo control, sir? So photo control is, you don't need to mark those points, but once you took the photograph, once later you took the photograph, you identified the you identified you identify the points which are feasible, that means what, sir? So once you took the photograph, this is the photograph, second photograph. So in the photograph you can identify any points, that is your choice. Certain elevation, certain points, maybe you feel that certain points are okay, this good, this puts this good, this good, this good. Later in this photograph also you can put certain points. Based on that photographs you can attach those photographs. So exactly matching matching these points, you can assemble like exactly matching. Okay, no need to put the marks on the ground, no need to put marks on the points on the ground. Directly once you took the photograph, later you can decide which points are better to reflect or better to identify. So those are the significant points in the photograph. You can choose those points, exactly match the other points. You can form the photographs, or you can assemble those photographs. Later you can form maps, contours, anything you can write, you can make it by these maps. Understood? So that is called a basic control, a photo control. So okay, this is a basic control, this is a photo control. This is a ground control, what is the horizontal control, and vertical control. So later you can feel it. So how can how how the point should be selected, how the points will be selected? Selection of photo control points, selection of photo control points. Okay, selection of photo control points should be sharp. Sir, sharp means like knife? No, sharp means it's compulsory, it reflects exactly on the photograph. Maybe some points are maybe dull, very little low height, you can't recognize in the photograph. That points are not sharp. Sharp means what? Some you can show some people, these people are very sharp. Sharp means not a, it's very thin. Okay, very reflective atmosphere. Okay, so point should be sharp and well defined, so that we can easily identified on photograph. Okay, easily identified on the photograph. So second is the position the position of photo control points on the photograph should be favorably located. Favorably located. So what is favorably located? Favorably located means, that means I said previously, Don't choose those points exactly 1 2 3 like this. You have to place one and one other, one thing, one here, one center, favorably located to match exactly to match another photograph. Don't took all points in surrounding to one point. We have to place those points spreading like anything. Choose another way. Okay, so that's it now. So that is the meaning favorably selected for your assembling is suitable. Okay, those are the favorably located. Okay, so that's it. That is the selection of photograph for counterpart. And how many number of photographs are tick? Number of photographs. See, number of photo control points. Number of photo control points. At least 3, maybe 4 is better. Not 1 is 2 is not. At least 3 or 4. Okay, 3 or 4 vertical, see, horizontal control and vertical control, both at least 3 horizontal control points, 3 vertical control points, at least 3 horizontal, vertical, 3 horizontal. Okay, that is the number of photo control points are required. So okay, so next, sir, these points selection looks like, so why required? So again, why is required? Photo control points are required. Why photo control points are required? So link between photograph, see, known position, link between known points and unknown points. So that's it. That's it. So for this purpose, the known points, how can you fix those known points? For this, just you can just see visible this purpose only. You can feel that known points, unknown points. Somewhere you hear this known. Somewhere you hear this line. If you fix the known points, you can find out the unknown points based on the positions of the other points. Where you hear? First unit, triangulation. So okay, triangulation. Are understood what is the triangulation? You can see first unit, first class. So where it is the first class? See what is the first class? Triangulation. See, the system consists of a number of interconnected triangles in which the length of the only one side is known, and the baseline and the angles of the triangle are measured very precisely. So what is primary, secondary triangulations? What is the purpose? What is the purpose here? Primary, secondary, tertiary, third triangulation. What is the purpose? If you know the points of those points and if you know the angles or bearings, you can find out the in-between points. That is the meaning, na? You can find out the coordinates of the in-between points. That is the triangulation. That's this, na? So we can took the examples of so arrangement of triangles, single chain, something, grid system, everything triangles. Where is those? See, double chain triangles, single chain triangles, braced quadrilateral triangles, control points. Based on that, you can find out the remaining points, in between points, in between points coordinates. You can find out that that is the triangulation basic motto. So same thing. Now you can feel that. You can feel that here also photo control points also we can fix those points based on the triangulation only. So that's why you call aerial triangulation. Aerial triangulation. That means what? You have to fix those points 1, 2, 3. Something. So if you fix those points, remaining secondary triangulation. Next fix those points. Next fix those points. Based on the known points, you can find out the positions of any points in the in the middle of those points. That's it. Now if you know this point, this has some bearing, this is the bearing. From this line, this has a bearing, this has a bearing. You can find out the position of the point. That's it. So in this also photogrammetric also, we have to fix those known points, or by the ground control. For ground control, we follow aerial triangulation. Aerial triangulation. So based on that aerial triangulation, we can fix those points on the photograph. Fix those points of the photograph. Okay. If you fix like this, you can identify the unknown points very easily, very precisely. Very precisely. Are understood? If you taken something rectangular way, you can't, it is not easy way to locate exactly the one point. Exactly, if you fix a triangle, so you can fix those points by the bearings. So it has a bearing, you can find out the position of that point. So triangle is very suitable. So in structural analysis also, you see every truss member is a triangle member. Triangle is basically something very unique in any finite element analysis. Any, if you took in any photograph also, if in three-dimensional photos, I see 3D printing. Every photograph, every three-dimensional objective, we divide into triangles only. Something, a picture of something is there, something a picture, something a picture is there, we have to divide every part into a triangles. Otherwise, you know it, just check it is every three-dimensional printing, everything we divide into number of triangles. That is very suitable, accurate, to find out the unknown points. So that's why they divide every part into triangles. Face, mask, everything. So very small objective, you can, if you see, for one dimensional you can took one point, for two dimensional you can took rectangular. But rectangle is not good, it can easily deviate. So it's deviate, small deviates, you can't exactly find out the unknown points with precisely. But if you took the triangle is a stable element. Triangle is a stable element. You can divide into every object into triangles, you can easily find out the remaining points, and those are the stable units. Later in in phds, you can find why it is triangle very suitable, how can we divide. So that is advanced topics, you can learn by your personal choices. Okay. So here also you can use triangulation elements, that is the aerial triangulation. Okay. So that is the purpose of, that is the aerial triangulation, means you have to fix those by the primary triangulation. Later you can choose subsidiary points for secondary triangulation also. Then based on those, you can easily find out the unknown points coordinates. Not only coordinates, unknown points position in the ground, in the photograph, those are the accurately matching. If you those are accurately matching, that's it, okay. Otherwise we can change the analyticals of photograph, we can change it, later we can assemble it. So analytical photogrammetry is also there, but it's not in our syllabus. Analytical photogrammetry, what is the analytical photogrammetry? Analytical means everything we discuss in the photogrammetry convert into the mathematical forms. So okay, matrices forms, and then interpreted into the computer language. So one language they develop, they will give every point coordinates, three dimensional view and 3D photographs based on these mathematical arts, and also three-dimensional coordinates it will give based on these mathematical equations and photographs. That is analytical photogrammetry. How can we change the mathematical equations? That is not required, no textbooks. If you do specialization photogrammetry, then only you require. Okay. So that's it. So that is the aerial triangulation. So we already discussed in a triangulation, so how these points are so located, how the baseline should be located, how the point should be, so how the triangle should be well triangle, what is well triangle, everything we discussed in a triangulation. Same thing here also, aerial triangulation. That's it now. That's it. That's the thing. So later next topic is how the photos are assembled. How the photos are assembled. So like this only analytical photogrammetry we will assign just small idea. So how the photographs are assembled. We took one photograph, that is a photograph. We called as a photograph. That's called as a photograph. If you assemble every photograph very simple manner, no need to take any reference points. Every just you can assemble it. Just assemble it. So you can see that this is like a map of that point. There is no control points. There is no control point. Just by visualizing, you can just attach it like this. It is called a mosaic. Mosaic. Just you can assemble. You just took a photographs and place on your table. Just assemble. Very normal. There is no control points. There is nothing. Just assemble. You get some map. That map is called a mosaic. Mostly this mosaic word we use when uncontrolled uncontrolled mapping. If you do uncontrolled mapping between those two photographs, uncontrolled mapping between those two photographs, you can call it as a mosaic. Okay, so that is a called mosaic. And also if you use use control points. What is control points? We already discussed ground control points, vertical control points. When you use the control points, when you assemble the photos, we call it as a controlled mosaic. When someone is called as a mosaic, that means it's uncontrolled mapping. You fix it without just just place it like this. When we use the control points, ground control points, based on the control points, you can fix those points. It is called a controlled mosaic. Okay. Total, without the total. So just only one line. If you only use only one line, it is called a strip mosaic. We can assemble those strips. You will get full map. That is called a strip mosaic. Take one strip, second strip, third strip. We can assemble every strip. Later we will get a total map. Are understood? Total map of that picture. So these are the certain times. So photograph and mosaic. What is controlled and uncontrolled mosaic? Strip mosaic. So that's it. So no need to nothing. Something index mosaic also there, but the same meaning. Index mosaic also there. Index mosaic also there. So that is also same definition. The index mosaic is prepared by assembling a number of photographs by matching the images. Just there is no control points. Just if you use the photographs by matching the photos. Just if you feel that something, if a image is there, okay, fix it. So just images. There is no control points. Again, there is no control points. If you just visualizing the images, okay, this image, this image, this image. There is no elevation difference, horizontal control, nothing. No need to follow. Just by looking and those images are matching, just took the images and you feel that okay, that's it. And you matching those images, that is called index mosaic. So that is the index mosaic, strip mosaics, control, uncontrolled and controlled mosaics. So if control mosaic is, will get map, full-fledged map. So see, just imagine, sir, this is very easy, sir. If you took the photographs, we can just assemble it, we can get the exact map. No chance. It's not easy by looking, okay, but in depth. So we already see by the taking the photographs we get the parallax error, something error. The height elevations are maybe different changes. So we will use 3D mapping, 3D analytical photogrammetry, making equations, then only give the some language they will develop a digital photogrammetry. That's the accurate map. But this is also a map, this is also exactly okay, but in the elevation very small differences will get. By just you can assemble those photographs by looking, by just assemble. Are understood? So that's it. So this is also you can, okay, certain, to get the idea about that location, you can use these mosaics, you can use these mosaics. But really you have to maintain exactly three-dimensional view, we have to maintain a software, we convert into the three-dimensional, we have to take care of the parallax error, everything we should take care and project it, and later we will get three-dimensional view, exactly elevation x and y z coordinates we will get it. That is exactly for these are the control mosaics, these are the just reference. Okay, got the point? So that's it. These are the, so see, mosaics just a reference, not an exact, not exact. Map you can call it as a map, this is an exact by a software, by a software. Mosaics is just reference point. Okay, just it. That's it. So that's it. That's the theory part. Those are the 3D part we have. Mosaics, horizontal control, vertical control, ground control. So everything we discussed in triangulation related to same thing. Okay, selection of the control points you can same lift out from the triangulation points, these points, how can you selection of the points. Okay, photo control points, basic control, photo control, triangulation, everything. This is the something theory part reference to the how we took the photograph, we already, how to interpret the photographs we already discussed, what is the scale, error, something, how to interpret the photograph we already discussed. But this is a before part, after part. Before we have to select some ground control points, later based on the ground control point we have to assemble those points like this. Okay, so that's it. If you see, if you see the something, you can, I will show certain today. So this is aerial photographs, you can see, you can see aerial photographs, stereo flatter. See these two photos assembled, you can just see, visualize how these softwares photographs, stereo plotter, everything, just look at it. So not at this PDF, some PDF, some photographs I required to show you. See, this is a photogrammetry as a course, 100 marks course, Sri Lanka. Okay, photograph, image, history of remote sensing we will discuss later. See, photographs, photography, why photogrammetry. See the maps, 3D points. See the close range photogrammetry, terrestrial photogrammetry, aerial photogrammetry, space photogrammetry. We won't discuss space photogrammetry. Space photogrammetry means satellites photogrammetry. Using the satellites to take a photographs, it's a satellite space photogrammetry. So height, you can't find out the height, elevation differences because there is large difference is there. It's a close range photogrammetry. Terrestrial photogrammetry we'll discuss next class. That is the last topic. Terrestrial photograph. See it is. This is aerial photogrammetry. Space. Space. No need, no need, no need. So oblique photos. Vertical. overlapping, see, mapping, low oblique, tilt images, high oblique, see the difference, high oblique, low oblique you will get certain coverage area, but if you see high oblique you will get more coverage area. Projection systems, so stereo pair, see the pairing, see the, this is one photograph, see this location is there here, another location is something else, so 60% overlapping na? Overlap is exactly 60%. See, so how the overlapping, stereo pair, see overlapping, see overlapping, side overlap also 20 to 30%. See, back olden days how they create a map. See this image I want to show you, that's why I took this PDFs. So they took all photos and they assembled. See, they have to try to assemble previous generation. Now it's a 3D modeling will come. We took the negatives, they provide they decode the negatives, and then later they have to assemble total area. See how house sketches, three-dimensional view, something sketches view, everything is in. So in this aerial photogrammetry, so these are the images, something contour lines, 3D building model, so everything, it's almost reaches to advanced stage. Just a photograph they can tell you what is your life also. That's nowadays it reaches too many heights. Okay, so we just giving the overall idea of what is photogrammetry, but it's almost, I think you already know it, drone cameras. By the drone cameras, very simple, take the photographs and they can locate, they can find out the every point positions. Okay, nowadays see the drift and crab, they include a certain, it's not good, it's not a good PDF. We'll see another, we'll see another photogrammetry. It's all three-dimensional modeling. He is in some advanced. He is an advanced, too much advanced digital photogrammetry. In this, any photographs are we will get it. Overlapping, 30% overlap, stereo vision, camera sensor, stereo, satellite image, satellite images. He only focuses satellite images. Okay, no need at all. But I want to show one last. What is one last? One simple video. No need of sound. Just listen. Just see it. No need of sound. That's why I want. Okay. Can you see it? Can you see it? Is no need of just normal Photoshop. I think you know already show what is Photoshop. So that's a very normal Photoshop technique. Normal technique. Normal Photoshop. See, mosaic. Mosaic. Mosaic means it's not an exactly three-dimensional view, just reference purpose. Just a photoshopping techniques. There is no reference points. Just based on the images, you just try to assemble. There is no reference points. There is no horizontal control, vertical control. Uncontrolled. See how difficult. See this problem. See the problem. How to solve those problems based on the reference points. See how he feels difficulty. This is called direct tracing method. Okay, direct tracing. Okay, this is called a direct tracing method. Direct. See how difficulty to assemble. That's why we required fiducial marks, coordinates, fiducial marks on the photograph, known points, positions. Everything is required. Not an easy to locate every details to match the between two photographs. And also we required at least 60% to get the parallax errors. So another method is there, నాట్ ఏ మెథడ్ సేమ్ మెథడ్. చిన్నప్పుడు మీరు చూస్తుంటారు కదప్ప, రెండు ఫోటోలు ఇస్తే ఫోటో గీయమంటే మీరు ఏం చేసేవాళ్ళు, కింద ఒక దాన్ని ఏమంటారు, ఆ, కింద ఒక లైట్ పెట్టి పైన లైట్ పైన ఒక గాజు పెట్టి దానిపైన దాని కింద ఒక ఆల్రెడీ గీసిన ఫోటో పెట్టి గాజు పైన మీరేం చేస్తారు, వైట్ పేపర్ పెడితే యాజ్ ఇట్ ఈస్గా బొమ్మ కనిపిస్తుంటుందా, సో దాని మీద మీరు రాసేస్తారా, బొమ్మ గీసేయచ్చు ఈజీగా. మేము చిన్నప్పుడు రికార్డ్స్ రాయమంటే అలాంటి టెక్నిక్ యూజ్ చేసేవాళ్ళం. ఆల్రెడీ ఒకటి రాస్తుంటే బొమ్మలు, సో కింద ఒక లైట్ పెట్టి పైన ఒక పేపరు దానిపైన గాజు గ్లాసు, దానిపైన నువ్వు వైట్ పేపర్ పెడితే యాజ్ ఇట్ ఈస్గా ఫోటో నీకు రిఫ్లెక్ట్ అవుతుంది. సో అలాగే ఎవ్రీ ఫోటోగ్రాఫ్ని we have to take a photographs, paper prints, take a paper printouts and assembled by a light reflector, assembled by a light. So how's the light? And light means if lights exactly reflect on the paper, you can exactly matching those details easily. మీరు చేశారప్ప టెక్నిక్ ఎప్పుడైనా చిన్నప్పుడు? మేమైతే చేసాం. ఆల్రెడీ ఎవడైనా రికార్డ్ రాస్తుంటే యాజ్టీస్గా డయాగ్రామ్స్, ఫిజిక్స్, కెమిస్ట్రీ కాదు, బయాలజీలో డయాగ్రామ్స్ మా వల్ల అయ్యేది కాదు. సో దానివల్ల కింద ఒక లైట్ పెట్టి ఎగ్జాక్ట్ కనిపిస్తున్నది వైట్ పేపర్ మీద, సో గీసేసేవాళ్ళం. సో దట్ ఈస్ కాల్డ్ పేపర్ ప్రింట్స్. Based on the paper prints, you can maintain the details or you can match those photographs certain level. That is called a paper printouts. Okay, paper printout method by light reflector. చేసిన వాళ్ళకి అయితే బాగా ఐడియా ఉంటుంటుంది. ఓకే, ఆ పని చేసిన వాళ్ళకి. సో లైట్తో రిఫ్లెక్ట్ చేస్తే నీకు ఫోటో ఎగ్జాక్ట్గా కనిపించేది. సో 2 ఫోటోగ్రాఫ్స్ని తీసుకొచ్చి అలా అసెంబ్ల్ చేసేసుకోవచ్చు ఎగ్జాక్ట్గా. ఇలా కష్టపడే బదులు మీ కింద లైట్ ఉందనుకోండి, ఫోటోగ్రాఫ్ వెనక లైట్ ఉందనుకోండి, ఎగ్జాక్ట్గా నీకు కనిపిస్తూ ఉంటుంది. అర్థమవుతుందా? సో దట్స్ ఇట్. దట్స్ ద ఎండ్ ఆఫ్ ది స్టోరీ ఆఫ్ ది ఏరియల్ ఫోటోగ్రఫీ. సో నెక్స్ట్ క్లాస్